Okay, so I mentioned earlier that we have two Van der Graafs here. And the way the Van der Graaf works is it has a motor down here at the bottom. It has this rubber belt attached to it. And so this rubber belt will rub on the motor down here. It actually has a piece of felt down here. And they'll rub against it, so the belt will charge by friction. And it actually takes the electrons off of it and sends them away to ground. So then the belt gets charged.
No, shut the door.
So then when the belt comes up to the top, it ends up charging this dome positively. It's taking electrons away. All right. So we're going to look at these different demonstrations here. So we'll start with the string and the ball. So that's this guy here. All right. So notice that I have a insulator here. I have an insulating string here, and then I have this ball here that's covered in metal. So initially, what's the charge on this?
Zero.
Neutral, right? So if I let this thing swing at this, it'll be attracted by induction. But once it touches it, what will happen?
Charge.
It'll have the same charge. Then what will happen?
Double charge.
It will be repelled, right? So y'all ready? So notice that it doesn't want to touch it anymore. Why not? Same charge, right? So they're doing what? Repelling. So I can make it charge it, I can make it touch it again and just discharge it. And there it goes. No, the Earth is neutral. But what I'm saying about the grounding is that the Earth can absorb a few million electrons, take a few million electrons away from it, and it's not really going to affect it because it's so big. I mean, technically it would have a charge at that point, but compared to its mass, it's negligible. Are we okay with this guy? Nice and easy. Alright, so let's talk about the snake here. So notice it's kind of the same setup here. I've got this ribbon here, and it's attached to this insulating rod. And this ribbon has some metal coating on it, so it can pick up a charge pretty easily. But unlike that ball, the ribbon doesn't really keep its charge very well. Hold it over?
Yeah.
Like that?
Yeah. It's like he's holding a wand.
It doesn't want to stay there for some reason. Why doesn't it want to stay there?
It wants to dance.
So we mentioned this last time in the notes. The gravity has this thing we call a gravitational field all around it that you can't see or touch or smell or taste, but you can feel gravity. Likewise, there's an electric field around this Van der Graaf here that you can't see, touch, or taste, but you can feel it when you get near it. Okay? So I'll make some of y'all touch this a little later. Alright? So there's our little snake. Alright, we got our piece of tissue here. Now if I just put a piece of tissue on here and I turn this thing on, what's going to happen? Why is it going to fly away?
Because it has the same charge.
It's got the same charge. So I've got a piece of tape here so it doesn't fly away.
Oh no.
So I'm going to tape it, it's going to stay stuck there. Because I don't want it to fly away. I want it to stay there. Okay? So, since there's this field here, I can interact with the field, and so therefore I can interact with this piece of tissue paper without touching it. Find your lack of faith disturbing.
thought that you were strong enough.
Oh, that's pretty good. Alright, what comes next? Oh, the 5 root. Such a fun one. Okay, so some of you may or may not have noticed that I don't really have any hair. I'm not as bad as Mr. Leffel, but you know. So I'm going to use this little guy here. It's going to be my substitute hair. Yeah.
The chair's not breaking.
What do y'all think of my hair? What's happening here? Why is it trying to stand up?
I don't want to touch that chair.
Come on, why is it trying to stand up? It has the same charge, right? So the charge, it's repelling. They're trying to get away from each other. But notice, it didn't just go up. It wants to get away from me.
Because you're touching it.
Yeah, because I'm charged, it's got the same charge. It doesn't want to be near me. Alright. So should I demonstrate the discharge now, or just...
Yeah, you step down.
Okay. We'll do that later. Okay, so... high plates. So what did y'all tell me would happen if I put that tissue on here without taping? Fly away. So what's going to happen to these little fly
They're going to float.
Why do they fly away?
Because they're the same charge and it would separate.
They have the same charge and it'll separate here. So they'll repel, right? Right. We'll do it in a minute here. Alright, so here, give me these puffs. Pick these up real quick.
I guess you say it was shocking.
Oh, you're learning something. Alright, we got 2 more here. Alright, so this little guy here is an electric whirl. Alright, so I need y'all to verify, audience verify. This has no batteries. Nothing magical about it, right? No. Right? Everybody's okay with that, right? Yes. So what I'm going to do here is I'm going to turn the Van der Graaf on. And so again, there's an electric field here. And so I can use this thing to interact with that electric field. And so what happens is there's more electric field on this side than on this side. And so the charges on it aren't distributed evenly. And so it creates this force which causes it to spin. They did pop a little bit. Don't worry about that.
I think the electric club just shocked me.
If I put it on top, will it fly away? That's a good question. Let's see what happens. Yeah, nothing happens because it's touching it. So since it's at the same potential, it won't spin. Alright. Light. Alright. Tyler, can you turn off the lights?
You want to start with the small one? You can do it.
Okay, what is this? It's a light bulb. Now notice, this is another demonstration about the electric field. Notice that when I hold it near it here, does anything happen? No. No. That's because the way the fluorescent light works, it has 2 ends, right? It has an end here, end here. And so it has to be, just like the electric whirl, it has to be at different ends, have to be near the Van der Graaf here.
Whoa. Your shoes are sparking. Mr. Bree.
But notice, it's actually using me to complete the circuit. So if I just hold it here in the middle,
Why does the shoe spark? Why does your shoe spark?
Well, the charge has got to go somewhere. Don't just stay in me.
Go to your heart.
That would be really cool.
Well, we can try it.
What happened if you put your tongue to it?
Well, you can find out in a minute. Use the smaller ball there. The question was, what happens if you put the bulb in between these two guys?
Oh, wait, there's more. Oh no. Whoa.
Silent.
Let there be light.
Been all night, the science guy.
So is it using me to ground out the bulb anymore? So notice that if I touch it, it doesn't really work. Okay? So it has to be off of it a little bit. Alright.
Has anything ever gone bad during one of your experiments?
Define that.
Explode.